Substance A is decaying exponentially and its mass is recorded at regular intervals. At time t years, the mass m grams of substance A is given by this. Find the time taken for the mass of substance A to decrease to 25% of its value when t is 0. Find the rate at which the mass of substance A is decreasing when t equals 5. Substance B is also decaying exponentially. Initially its mass was 40 grams and 2 years later its mass is 31.4 grams. Find the mass of substance B after a further year. Okay, here's the question then. In summary form, there's the equation above. Find the time to decrease by 25% from when t is 0. So part A of 1, t equals 0, we can see that we know m is 40. We can just look at it here, for example. Put t as 0 in here, e to the 0 is 1. 40 times 1 is 40. 25%. So for it to decrease by a quarter, so when m equals, take a quarter of that is 30, when t equals what? Let's put it in then. So here, so 30 is equal to 40 e to the minus 0.132 t. So cancel by 10 both sides, and that tells us 3/4, move the 4 from times to divide, is equal to e to the minus 0.132 t. And then take logs to base e. Basically, to write this as a logarithm, natural logarithm of 3/4. So the e comes down to be the base number, and then this is just minus 0.132 t. So I've written this equation in integral form in its equivalent logarithmic form here by simply moving the e to be the base number. And this power term just drops down to ground level. Then divide by the minus 0.132. And we have this, don't we? Move that down to divide. Log of 3/4 is equal to t. So I'm going to tap that in the calculator. So minus 1 divided by 0.132 times by the natural logarithm of 3 divided by 4 equals 9.620, and that was to 2 dp. So that's when it's reduced by 25%. Time taken, so 9.62 years. Okay, so find the rate at which m is decreasing when t is 5. So let's differentiate to get the rate of change of m. So b, m is equal to 40 e to the minus 0.132 t. So dm dt, differentiate with respect to t, function of function. So e to the something goes to e to the something, multiplied by the something differentiated, and this would give 40, there's 40 lots of, and then multiplied by the minus 0.132. Okay, so find that when t equals 5, 40 e to the minus 0.132 times 5 times minus 0.132. So let's work that out then. Tap it in the calculator. 40 times the exponential of minus, let's just go back, put a minus in. 132 times 5 down to ground level times minus, so bracket negative 0.132, close that bracket, equals minus 2.7289 minus 2.73. That was the 2dp. Okay, that was dm dt after when t was 5. That's part B. Substance B is also decreasing exponentially. Initially its mass was 40 grams and 2 years later its mass is 31.4 grams. Find the mass of B after a further year. Okay, so this is part 2. So mass of B, which I'm going to call M dashed, I think is probably a... Well, let's just denote it as mass of B. That'd be best. That's equal to 40 e to the alpha t. Right, so we know it's decaying exponentially. So that was the model. Initially it's 40, so we put 40 in, and then 2 years later its mass was 31.4. So we put 40 in here because we know that when t is 0, mass of B is 40. T equals 2 gives 31.4 then is equal to 40 e to the alpha times 2. So that tells us then that 31.4 over 40 is equal to e to the 2 alpha. So we just move the 40 from times to divide, and then that tells us that alpha is equal to, take the base logarithm, so it'd be 2 alpha is equal to the log of, and I'm going to times this top and bottom by 10, 314 over 400. And then alpha is equal to half, and then 314 over 400. Okay, that's alpha. So when t is 3 then, when t equals 3, mb is equal to 40 e to this value times t, which is 3. So what have we got here then? Because t was 3, wasn't it? So we put 3 in there. So MB will be 40 E, and this would be ln. And 3 over 2, lots of log, will be 314 over 400 to the power 3 over 2, won't it? Using properties of logs. Now we've got an E logarithm, so they cancel each other out. So it's 40 times 314 over 400 to the 3 over 2. So let's tap that in the calculator then. 40 times bracket 314 divided by 400, close bracket, power, we could put 3 over 2 or 1.5, 27.82, 27.82 grams to 2 decimal places. So I've just looked at the question again to double check everything, and I've noticed that I've got question 1 not correct, mistaken here because I've misread it. It says find the time taken for m to decrease. I've put by, but actually in the actual question that I failed to copy correctly, it was to 25% from when initially t was 0. So instead of m being 30, we want to decrease it to 25% of its original. So here m would be 10. So this would be 10, wouldn't it? So let's just make this change then and edit this. 10, and this would be a quarter, wouldn't it? Here. And this would be a quarter here. Let's put them in. And then we'll tap it in the calculator. And hopefully we'll get it right. So this will be log of 1/4 instead, won't it? So a slight mistake there. So let's tap it in the calculator. 1 divided by 0.132 times ln of 0.25. 1/4. And don't forget there's a minus at the front of it. So minus the minus is 10.50. So 10.50. That minus I didn't put in, so it becomes a plus, and it was 10.50 to 2dp. The only other thing to say about B, this would be marked correct here, but actually the question did say the rate of decrease, and dmdt is the rate of increase, so being more pedantic about it, this should be 2.73, because dmdt is the rate of increase, this is negative, so the rate of decrease will be the positive value here, 2.73, but this would also be marked correct.